Congratulations everyone, we made it to the last section of Physiological Optics 2. In this last section of Physiological Optics 2, we're going to go over accommodative demand. We're also going to talk about prescribing ads for presbyopic patients and a couple of different methods of being able to do that. And then we're going to finish up talking about classifying astigmatism. All right guys, let's get started. So the first thing we're going to do is going to go through examples 6.15, 6.16, and 6.17 talking about Joey and Mary. So to do that, we're going to take it to the whiteboard. So to calculate Joey's accommodative demand uncorrected, right, what we need to do is we need to first figure out what's going to be his demand at that 23 centimeters because that's where the object is located at, right? So we're just going to take 100 over 23. That's going to give us 4.34 diopters. We all got that. Now, the hard part with accommodative demand is trying to remember, okay, if the patient is uncorrected myope, does that mean I subtract out their prescription or am I supposed to add their prescription to get their total amount of accommodation needed, right? And the key point here is remember, because he's an uncorrected myope, right, that's going to help him out, right? He's not going to have to accommodate as much to be able to see things up close because his natural far point, right, is going to be 33 centimeters in front of his face, right, in front of his eyes. So what you're going to do is you're going to take that 4.34 diopters accommodative demand at 23 centimeters, you're going to subtract out his uncorrected myopia, right, because that's the eye is has more converging power because it's myopic, right? So you're going to subtract that out and you're going to get 1.34 diopters for their total accommodative demand, right? So that's going to be for your myopes, right? So uncorrected myope, you're going to subtract out their prescription, right, to get their total accommodative demand because they're going to be accommodating less to be able to see at that 23 centimeter mark. Very good. Now, let's talk about Joey again. So what would be your answer to the previous question if Joey were an emmetrope, right? Let's just say Joey had LASIK, right? So Joey had LASIK and he's now an emmetrope. What's going to be his accommodative demand at 23 centimeters? Well, yeah, it'd be exactly the 4.34 diopters that we calculated, right? So that's going to be easy. You guys see that. You're going to dominate that. Keep on going. All right, let's talk about Mary. So Mary is going to be example 6.17. Find the uncorrected accommodative demand for Mary, right, a 3 diopter hyperope to see a distant object, okay? And then also, what if the object were placed at 23 centimeters as before? All right, so why don't you guys take a second, work that example, and then we'll come back and work it together. So what's going to be Mary's uncorrected accommodative demand at distance, right? Well, if she's a 3 diopter hyperope, right, remember that her eye is too weak by 3 diopters. So for her to be able to see a distant object, she's going to have to accommodate 3 diopters to be able to see that distant object clearly, right? Okay, now what if the object was placed at 23 centimeters as before? Well, we already calculated that at 23 centimeters, the demand is going to be 4.34 diopters. But here the key point is, okay, do we add or subtract that uncorrected hyperopia, right? Well, we have to add it, right? Because not only does Mary have to accommodate to go from in distance to 23 centimeters, 4.34 diopters, she also has to accommodate 3 diopters at distance to see clearly because her eye is too weak, right? A hyperope's eye is too weak converging power, right? So what we're going to do is we're going to take 4.34 plus that 3 diopters, and we're going to get 7.34 diopters as the accommodative demand for Mary. I want to walk you through a summary of accommodative demand. This is a topic that I have found to be very challenging for a lot of students as I've been working with them over the past whenever they're doing their boards prep. So I kind of came up with this summary and I hope this will be helpful there for you. So as I'm walking you through this summary, please feel free, take time to pause the video and be able to write this summary down here in the bottom of your book, right? So if you have an uncorrected hyperope, right? So an uncorrected hyperope, right? Or they have a minus lens over the eye, right? Both of those situations are going to cause a patient to have to accommodate more, right? To be able to see an object clearly, right? So if their patient is an uncorrected hyperope, right? Or you put a minus lens over a patient's eye, right? That's going to cause them to have more accommodation is going to be needed, right? So whenever you go to figure out their accommodative demand, you're going to add in their amount of uncorrected hyperopia or add in how much more minus you're giving them over their eye, right? Because that's going to increase their accommodative demand needed. Now, if a patient is an uncorrected myope, right, or you put plus lenses in front of their eye, right, then what that's going to do is that's going to decrease their accommodation, right? So they're going to have less accommodation that's going to be needed, right? So you're going to subtract out that uncorrected myopia, just like we did with Joey. We subtracted out his uncorrected myopia to get his accommodative demand, or if you put a plus lenses over a patient, right? So uncorrected hyperope or a minus lens, more accommodation needed. Uncorrected myope or a plus lens, less accommodation needed. Let's continue on in this section talking about different methods that we can use to be able to find a patient's presbyopic ad that we would want to give a patient, right? So we've got 4 main ones here are going to be in the book, right? So the first is going to be your half amp method. It's not very clinical. but it makes for good optics related questions, right? So that's why we want to go through it. So if you guys look at that, so there's 4 main methods here. Number one is going to be the half amp method. Remember, we wanted to keep half their accommodation in reserve, right? So the half amp method is going to be the add power is going to be equal to their working distance minus 1/2 their amplitude of accommodation. So we've got that equation here in the book. You may just want to write it to the side. Add equals, right? Working distance minus 1/2 the amplitude of accommodation. Good. And you've got the example there in the book. I'll let you guys work through to dominate this topic. Let's go on and talk about the second method is going to be balancing your NRA and PRA, right? So if you balance your NRA, PRA in your testing, you'll be able to get a tentative add based on that as well. So you guys want to highlight that there. That's going to be in the text so that the patient's prescribed add is in the middle of your NRA and PRA range. That's just 3 lines down there for those of you guys that want to highlight something. If you move on, we've got an example there. I'll let you guys work that'll walk you through balancing your NRA, PRA, and then we will continue on. We've got 2 more to talk about. Fused cross-sill, right? So a lot of us like to use the fused cross-sill test, which we'll talk more about in binocular vision, and it's in that section where it goes in more detail about that. But you can use the fused cross-sill to tentatively determine a patient's add. It also tells you their lag or lead in accommodation. Right? Remember that 2 uses of the fused cross-sill. And then also you've got your age-based norm. So this box here on the bottom, to me, that's the most clinically useful one. You know, I obviously balance NRA, PRA, and I fuse cross-sill whenever I need to. A lot of times, though, whenever I'm prescribing the add, I take and go, okay, the patient is going to be, you know, 45-year-old. I'm probably going to be around a 1 to 1 1/4, right? So I think that box is really good. I put a highlight around that box and kind of look through and know those numbers as you're going through. But like I said, I think clinical useful there. All right, let's continue on and talk about aphakia and then finish up talking about astigmatism, right? So 2 more topics, guys. Hang in there. You're doing great. So whenever we talk about an aphakic patient, right, we're talking about somebody that had a cataract removed, right, and did not have an IOL or put back in, right? So they are without a lens inside their eye. So essentially what that means is that you are removing more of the converging power of the eye, and so their eyes are extremely weak at converging, right, light. And so what they are is they are effectively a very, very high-powered hyperope, right? Their eye is very weak, right? And so what's that going to lead to? So whenever you go to correct a patient with an aphakia, right, what's that going to happen? We're going to give them a lot of plus power in lenses, right? And so what are 2 problems that could come up with a patient that we give a high plus power, like plus 10, plus 12, plus 14 power to? Yeah, exactly right. One of them is going to be a distortion, right, that we talked about earlier in the aberrations on physiological optics. One, you guys, which one it is? Is it going to be pincushion distortion or barrel distortion with a high plus powered lens? Remember, count your P's, right? So pincushion plus, right? So with a high plus power lens, they're going to be more likely to have pincushion distortion. One of the other things that can happen is a ring scotoma that the patient may have because they have such a high plus powered prescription, right? And if they're aphakic in one eye and not the other, then what they can have is they have a huge aniso difference, right? They're going to have a lot of anisoconia there that's going to cause them trouble as well. Last thing we'll do is kind of tie in some disease into this, right? If a patient is aphakic, what's going to be a potential problem for them, right? And that's going to be macular degeneration, right? They're going to have increased UV light exposure to the macula, right? So that's going to put them at an increased risk for developing macular degeneration, right? Because the lens is not going to be able to be there to be able to absorb that UVA and UVB light, right? And so because that lens is not there, more of that light's going to be getting into the back of the eye. So with our aphakic patients, really important to make sure they have correction that's going to have UV protection on it. Great, guys. Let's keep on going. Let's finish up this topic talking about astigmatism, right? So real easy review here. This is the last topic here. Real easy. So let's talk about a couple here. Simple, compound, and mixed astigmats, right? So for simple astigmats, remember we have one line image is going to be on the retina. The other one's going to be either in front or behind the retina, right? That's your simple. Your compound astigmat is going to be both line images either in front of the retina for a compound myopic astigmat or both line images behind the retina for a compound hyperopic astigmat. Your mixed astigmat is going to be one line image in front of the retina, one line image behind the retina, right? And then your equally mixed astigmat is going to be that they're going to be equal distant, right? So your line image in front of the retina is going to be equal distant to the line image behind the retina. Essentially what that means is for an equally mixed astigmat, right, the spherical equivalent of that prescription is plano, right? So that's what I'd write to the side, right? Spherical equivalent of that prescription is plano. The circle of least confusion falls on the retina. That's that last line. You can highlight that. All right, let's talk about the major meridian of the eye. So whenever we use major meridian here, what they're talking about is what's going to be the most plus powered meridian or the steepest meridian typically, right? So steepest meridian, the major meridian is going to be the meridian with the most plus power. So when we talk about with the rule here, we're talking about, that's going to be, whenever thinking about, it says with the rule, astigmatism corresponds to astigmatism where the cornea's major meridian is vertical, right? We're talking about on the cornea, right? So whenever you look at the cornea, right, with the rule patient, right, their steep meridian is going to be vertical, right? So another way to write that is just write steep meridian, right, where it says major meridian is vertical, steep meridian is going to be vertical. So if you go on and against the rule, right, it says that astigmatism where the cornea's major meridian is going to be horizontal, right? That's going to be once again talking about referencing the cornea, right? So against the rule in terms of the cornea is going to be where the steep meridian is going to be horizontal. Then if you look in that text, you're going to see a box there. It says in terms of a lens prescription, that's going to be in terms of glasses, right? Where your with the rule is going to correspond to axis that is approximately horizontal, and your against the rule is going to be approximately vertical. So the key point there with that box is just write glasses right above that, because that's something that's I have seen to have some confusion with students on that part, all right? So just write glasses out to the side. All right, guys, we're done with physiological optics 2. You guys did a great job with this subject. Keep on dominating. We'll see you on the next section.